We need our DFM data frame again. We're going to run a couple of filters on it before we move on to our next section. We performed this indexing from here on up in our previous lesson, but we didn't really get to these Boolean slices. So let me run this DFM data frame here so we can look into it. And we have this one column here. It's the first column in our array. What we're asking here is to return an entire row where the value in the ones column is less than or equal to 8. We're looking at the values in this one column and selecting by these values. And here we are equal to 8, so that will be returned. And in Ohio and Colorado we're less than 8, so those will be returned. But New York is obviously greater than 8, so New York won't be returned. So let's run this. We can make selections by Boolean indexing here. We can also get a complete sister data frame of Boolean values by asking the question, which values in the DFM data frame are less than 3? Well, by inspection, we can tell that 2, 1, and 0 are less than 3, so these should come back true, and the rest of these items should come back false. So let's run this, and that's what it turns out to be. And we can also set values in this way. We're saying here that in every case where a value is less than 4, so that's going to be this first row, right? 3, 2, 1, and 0, those are less than 4. Well, in those cases, reset those values to 555. So if we run this, we see that through this indexing we can set data just as easily as we can request data. Now we've used the iloc selector before, but I don't know that we've used iloc. So let's begin talking about iloc. Iloc obviously means location, and I means indexed. So with iloc we search using an indexed selection. So here we're looking for row 0 and item 0. If we run this, it should return this 555. Actually, we should reset this. Where is it? Let's reset this to its original values and run this again so we can tell what number we're getting here. Let's run that again, and we get the 0. We should output this again so that we can see it. Yeah, so we get the 0. Alternatively, we can use just double square brackets instead of the comma. And that also returns a 0. What do you think happens if we change this to a 2? 0, 1, 2, so that'll probably be Utah. And let's change this also to a 2. And that should be 0, 1, 2. Perhaps we'll get a 10 from this. Yes, we get a 10. Of course, we could just simply put a comma here in place of that, run it again, and we also get a 10. We can also request data by slice. And here we're asking for the row, and here we're asking for the column. We want to get the data from rows 0 inclusively to row 3 exclusively. So we're going to get rows 0, 1, and 2, but we're not going to get row 3. And then we also want to do the same thing here. We'd like to get from column 0 through 0, 1, 2, 3, but 3, remember, is exclusive, so we're just going to get these values. So we'll get this rectangular matrix here. From this, let's run it and see what we get. So indeed we get Ohio, Colorado, and Utah, just as we predicted, and we get 1, 2, and 3, just as we predicted. So up until now we've been using iloc. We've been grabbing values by index and by slice. What if we want to select multiple indices without using a slice? Well, then we use the same comma separator where on the left side we're getting rows and on the right side we're getting columns, but we need to pass a Python list in here to hold the rows and columns that we want. So this should return just 0 and 1 and just 0 and 1, right? So let's run this and see what we get. Yeah, we get 0 and 1, Ohio and Colorado, and we get 0 and 1, 1 and 2. So up until now we've been using iloc, so we're grabbing locations by index. Down here we're using iloc. We don't use the index, we actually use the labels. And just so that you know, these user-defined indices are called labels, and these column titles also are called column labels. So we're requesting items by label now. but actually we're doing quite the same thing. We're using a comma separator and saying to the left side we want to get the row, and to the right side we want to get the column. So let's run this, and we should return a 0. Using iloc, we can also get more than one column. Again, using a Python list. On the right side, we're requesting 2 columns, but we're only requesting 1 row. So let's run this. From Ohio, we're getting the value from row 2 and from row 3, so we get a 1 and a 2. And finally, if we want to get more than one value from the rows and from the columns, we simply use a Python list on the left side for the rows and a Python list on the right side for the columns. And you can predict what we're going to get here. We just get this 3 by 3 matrix.